Now, what's one of the most important pieces of our Foundry that we should absolutely get right? Well, obviously the funding. We want to make sure that this conversion rate is actually working. And in order for this conversion rate to actually be working, we need to make sure that we're actually able to get the version from our aggregator v3 interface. We're able to interact with them correctly. Let's use this get version function to try testing if our price feed integrations are working correctly. We know from Remix that this get version should return version 4. So what we can do is we can go back to our test now and write a new test. We can say function test price feed version is accurate. This, and we'll say now, we'll say Foundry dot get version like this. This should return 4, and that's a uint 256. So we could say uint 256 version equals Foundry.get version. And then we could say assert equal version 4. What do you think will happen when we run this test? Do you think this will pass? Go ahead, pause the video and write down what you think will happen. Well, when we run forge test, we actually get an EVM revert. Why did this revert? We don't really have that much information. Now, something that's really annoying is that we're still running these tests and we don't care about them. So what we can do is we can double click this function, copy it. Let's clear the terminal. We can do forge test -m, paste this in here, and now we'll only run that single test. Awesome. But we still don't have that much detail in here. Okay, let's clear. Let's change the visibility using 2 Vs. Okay, that didn't really do anything. Let's use 3 Vs. Oh, now we got some more information here. It looks like we get what's called a stack trace of the error that we're getting. And it looks like we're calling our Foundry test. We're calling this test price feed version is accurate. We're calling get version, and that get version is reverting. It doesn't tell us why it's reverting, but we know that it's reverting because we're calling a contract address that doesn't exist. Remember, when we run tests in Foundry, when we don't specify a chain, Foundry will automatically spin up an Anvil chain and then delete it right after the test is done. So when we run forge test and we don't give it an RPC URL, it's going to spin up a completely new blank Anvil chain and run our tests. And we're making a call to a contract that doesn't exist. So obviously we're going to get an error because nothing exists at that address. So what can we do about this? Well, we can do a couple of things. And in this course, we're going to talk about 4 different types of tests: unit, integration, forked, and staging. Forked can kind of be considered like a unit/integration add-on, but I think it's important to call out as something a little bit different here. This is something known as a unit test. A unit test is where we test a very specific piece or a specific part of our code. For example, here, we're testing a single function. We're testing get version. We're testing to make sure that works correctly. So that's going to be considered a unit test. However, one could argue that it's also an integration test because we're testing this function works, and this function actually calls out to another contract. So in this case, we're testing actually multiple different contracts are working correctly together. A forked test is when we test our code on a simulated real environment, and we'll talk about this soon. And staging test is actually when we deploy our code to something like a testnet or even a mainnet and run all of our tests in that real environment to make sure things actually work correctly. These are all important and they have different trade-offs and they have different best times to use them. For the purposes of this course, we're going to focus on number 1, kind of number 2, and especially number 3. We're not going to do too much staging tests in this course. However, it is definitely something important, definitely something to consider. I've seen protocols skip this step and get screwed because their production environment was completely different than their testing environment. And I'll explain what this actually looks like in a little bit. But let's go back to the problem that we're working with here. What can we do to work with these addresses outside of our system? How do we test our test price feed version when we're working with Forge and Anvil? Well, one thing that we can do is when we run our command here, we can pass what's called a -- fork URL. And we can go back to Alchemy. We'll sign back in and go to we'll grab our API key. And just so that we'll have it, we're going to create a .env. We're going to say sepolia RPC URL equals that. And we're going to make sure The .env is in our .getignore. Okay, great. And then actually let's run source.env. So now if we run echo Sepolia RPC URL, we see that we're successfully using this as an environment variable. But if we hit up a couple times, we can now run this test price feed version is accurate with a --fork -URL $Sepolia RPC URL. This is how we access our Sepolia environment variable. And what will happen is Anvil will actually get spun up, but it'll take a copy of this Sepolia RPC URL. It'll spin up an Anvil, but it'll simulate all of our transactions as if they're actually running on the Sepolia chain. So it'll pretend to deploy and read from the Sepolia chain as opposed to a completely blank chain. So if I run this now, what do you think will happen? Whoa, we see we go ahead and we get an OK here. We can see we're getting returned the hex value of 4, and we can see that in our test here, we're actually getting 4 returned. And if we go over to our alchemy node, we hit a little refresh here, we can scroll down and we can see recently we made a whole bunch of calls to our alchemy node. When we use a fork URL, we're going to simulate what's on that actual chain. And this is a great way for us to easily test our contracts on an actual network. Now, the downside of doing these forks is that you're going to make a lot of API calls to your alchemy node, which can run up your bill, which is why I still think it's important to write as many tests as possible as you can without forking. But there's going to be a lot of tests that you have to run that can only be done on a fork or using mocking to make sure that we get plenty of coverage to test all of our contracts. And that's another interesting thing that you hear me talk about is coverage. So if we delete all this, we can also run this thing called forge coverage. And then if you do dash RPC URL or fork URL, those are the same thing. And we can actually see how many lines of our code are actually tested. So if I run forge coverage with fork URL, we'll run our entire test suite, and then we'll actually see how much of our test suite, how much of our code is actually tested. Right now, as you can see, a lot of our code is red and not tested, right? Fundme.sol has barely any tests. PriceConverter.sol has barely any tests. We want to get this up as high as possible. Now, sometimes it's infeasible or doesn't make sense to bring this up to 100%, but 16% is incredibly low. As we're continuing with this course, I'm not always going to write tests that bring us up to 100%. And the times that I don't, it's on you to actually try to see if you can bring the number up higher, or if it even makes sense to bring the number up higher. But in any case, we're going to set up our contracts here to write an elaborate set of tests so that we can maximize our test coverage. We can write unit tests, integration tests, fork tests, and staging tests, and all that good stuff. And if this is a little bit confusing to you right now, this is one of these times when I am going to say, don't worry. The more we work with it, the more that it'll make sense to you. Just continue to follow along with me for now, and it'll become clear as we do more of it.